these notes really should be quite brief because it's the water cycle. And who in here knows the water cycle?
I don't know the other thing, that is not the evaporation,
Yeah.
Okay, most people understand evaporation, condensation, precipitation, and runoff. Okay. As we deal with stuff today, we're going to talk about some concepts. I'm going to add to it transpiration. We're going to talk a lot about groundwater in this unit. A lot about groundwater, surface runoff, a little bit about heat exchange. So this will be quick. This will be painless and easy. Okay. So some quick notes. This is mostly vocab, so I'm just going to talk about some vocab words. Okay. Evaporation is very simple. Water changes from liquid to vapor. Liquid to vapor. Okay. When this happens, it takes heat to evaporate water, right? Okay. My fish tank at home, I have to constantly add water to it because I'm heating the water. The water is warm and it's evaporating. You can look at the fish tank back here and you can see how much water has evaporated out of the really nasty fish tank since the beginning of the year. I should clean that.
Yeah, you should.
Okay. One, two. So I should.
You should leave it there.
Okay, so this is when water is changing from liquid to vapor. Now I said heat was involved. That heat is then captured. The heat is absorbed into the water vapor. It takes a lot of energy to evaporate water. That energy is held on to. Okay? Now transpiration is kind of in the same category. This is where you have a tree. Somewhere else. This is where you have a tree. Okay, you've got a goofy looking tree because you can't have normal looking trees. Okay? The trees pull in groundwater. Water right around them. Actually, trees are known for pulling hundreds to thousands of gallons of water daily. They suck up lots of water. Well, the water comes up the trunk into the leaves, and through photosynthesis, it's using water as part of that process of making plant food. But a lot of the water is also ejected out of the leaves in the form of vapor. So the trees absorb water, then they expel the water vapor through their leaves. So areas around a forest, would you expect it to be dry or humid? Humid. Okay. So what's really cool here is, if you think about it, forests are areas where it tends to rain more. Now the question is, does it rain more because there's a forest, or is the forest there because it rains more? Both. It's both. Forests grow in areas where there's lots of rain because trees require tons of water. Areas where you don't have tons of water, like Kansas, you get more of a prairie. Lots of grasses but not a lot of trees. Areas like Virginia, where tons and tons of rain, everywhere you look there's trees. But at the same time, the trees produce very humid areas, a lot of evaporation, a lot of water in the air means it tends to rain a lot more in these areas. So kind of both. Okay, so evaporation, transpiration. You might even hear this called evapotranspiration. Evapotranspiration, because it's the same basic process, except one's coming through plants and one's coming through just straight evaporation. You guys have any questions on evapotranspiration? Okay. We'll move on then. Okay, I gotta erase my gorgeous tree. Okay, so that's evaporation. Okay, stage one. And there's condensation. Stage two. Okay, condensation. If something's going to condense, yeah.
It's forming.
What? Last class. Take it today. Okay, condensation. Okay. Here. Condensation. As the air cools, water changes from vapor to liquid. Okay, to evaporate the water, you have to add a tremendous amount of heat, so that heat is captured. As the air cools, as water in the air is rising in the sky, right? Air tends to rise when it's heated. It rises in the sky. Well, the higher you go in the sky, the cooler it gets. So the cooler it gets, as it's rising, it's getting colder and colder and colder and colder. It reaches a certain point in the sky where it can no longer, it's too cold, the air can no longer hold the water, and boom, it changes from that from the invisible water vapor to liquid water in the sky. Then that heat is released, and that's how heat transfers across the, one of the ways that heat transfers across the globe. Okay, water, but what does this, get all tongue-tied this morning, sorry guys. In order to get liquid water in the sky, the water has to condense on something. So you know this concept in the summertime. You've heard this in probably every grade since you were in kindergarten. You pick up a glass full of cold water in the humid summer heat. What forms all over the glass? Fog. Water condenses all, so you have a wet, slippery glass. You didn't hold on to the glass, it falls to the ground. It's not my fault, I didn't spill any. And then your mom's like, what happened? You've heard that analogy, right? Okay. That's water condensing. The water condensed on the glass. If you go out early morning, the sun's just coming up, and you step in the grass and your feet get wet, even though it didn't rain, what happened? What do we call that? We call that dew, D-E-W. Like Mountain Dew, right? The whole concept of Mountain Dew is like you're drinking the dew off the grass in the mountains, but it's really a high fructose corn syrup sugary drink of awesomeness. Okay. But the dew. Well, water's condensing on the plants and the rocks and the whatever is out there, and you get the dew. Now, but when you're in the sky, you don't have plants and rocks and mountains necessarily. But you do have dust, you have dirt, you have ash particles, you have all kinds of pollen and just stuff in the air. So if you look through a light, I don't know if you can see even through this light, you can see particles of dust floating.
Yeah.
Okay, that's all over the sky. There's dust all through the air. Water will condense on those little pieces of dust, and it forms raindrops. Those little pieces of dust, we call those condensation nuclei. Write that down, you'll see it again. Write it down, you'll see it again. Condensation nuclei. Okay? Here we go. So once again, this heat is released. I'm not going to get too much into latent heat transfer and heat being absorbed, heat being released. I just want to introduce you to the concept that heat is released when it condenses, because that will be very important when we get to meteorology, the study of weather. But for right now, in the basic water cycle, heat's released when it condenses. Questions, comments, concerns? Cries of outrage? Okay. Precipitation, step 3. Okay, so we have this water, it evaporated, absorbed heat, it then condensed in the sky, released its heat, and now there's enough water in the sky, it's either getting too heavy, something shifted, it is no longer able to remain floating in the sky, so that liquid water, gravity wins, it starts to fall down. So you have a lot of liquid water falling down to Earth. Well, that's precipitation. Pretty simple, right? So precipitation, you could have rain, liquid water. You could have snow, crystallized water. You could have sleet, frozen water. There's actually a difference between crystallized and frozen water. I mean, snow, you guys know the difference between snow and sleet. They're both frozen, except the snow had a chance to slowly cool, right? Because bigger crystals, slower rate of cooling. And the sleet freezes quickly, usually as it's already falling. And then you get nasty conditions like we had just a couple days ago. On Saturday was ugly, it was sleeting, it was really bad. Okay. And then you have hail. Now hail is also frozen water, except it's different. It's formed the same, similar way that sleet is formed. Rain is falling and it freezes. But this actually happens completely in a cloud. So you have a piece of water that freezes, and as it's falling, well, it's a pretty big thunderstorm, so there's a lot of what we call updrafts, where the air is being pushed back up in the cloud. So this water drop goes on this journey between frozen, liquid frozen, and each time it goes around that journey, it gets a little bit more water on that little piece of ice, and it gets bigger and bigger and bigger. So thus you have hail from various sizes, from the size of sleet to the size of grapefruit. You know, they can get really big. In my family, we had a big storm down in Texas that there was a piece of hail, softball size hail, and it actually went through the roof. One of the pieces of hail went, and they had metal sheeting in the roof to protect from hail, went through the metal sheet all the way into the house. Big giant piece of hail. So that's formed from big storm clouds. Once again, we're going to get to all this much later in meteorology. Okay? Questions? Concerns? Cries of outrage? Four. Runoff. Okay? Runoff is where we're going to focus most of our attention for the rest of this unit. Well, water pools on the earth and flows downhill toward the oceans. Right? Water forms in the street. It runs off. You have excessive runoff in cities. Rivers tend to flood more in urban areas because water can't absorb into the ground. So it's kind of a neat factoid. If you want to know where the floods are worse, it's always going to be near a city. I'd like to think you guys know what rivers and lakes are. You're going to take a remediation class. What we're really... Okay, groundwater is what we're really going to focus on. We'll talk a little about rivers and lakes, but we're really going to talk about groundwater. We're going to talk about the water table. We're going to talk about the zone of saturation, the zone of aeration, and a lot of stuff that I haven't put up here yet. Zones. We're going to talk about porosity and permeability. We're going to talk about groundwater contamination. So this is really where we're going to focus. But in order to understand groundwater, you kind of have to understand the basics of the water cycle. So pretty simple. Now, here's something that's very key, and if you haven't written this down or you're not paying attention, pay attention to this. Water flows downhill.
It never goes up there.
Okay. But when you're underground, it will follow the slope of the water table. Water always flows downhill. The water table does not always match where the hill is. We'll talk about that later. Okay? And groundwater can also, it can be trapped underground for thousands of years, if not longer. There are underground rivers and lakes. There are caves full of actual rivers and lakes, but an underground lake would be an aquifer, and those aquifers actually flow with water. Okay, so that's runoff. Yeah. So that's the water cycle. Do you guys have any questions on the water cycle?